In this class, we're going to take a look at what's called the CAST method, or the CAST diagram. So CAST stands for cosine, all, sine and tangent. So cosine, all, sine and tangent. And it's just another way of representing the information from a sine or a cosine or a tan graph. It's a more kind of compact form. It just allows us to gauge some trigonometric values. So let me show you what I mean by that. So let's say we start with a sine graph. Let me draw the sine graph here. So I'm assuming that you're already familiar with a sine graph. If not, then that's okay. You can just kind of follow along. But if you sketch the graph of the sine function, you basically get this wavy graph that looks like something like that. And one of the features of this graph is all of the key points occur every 90 degrees. So this point here, which corresponds to the highest value, is at 90. Then this one here is at 180, then 270, and then 360 on the end. So we can kind of divide this graph into four 90-degree chunks. So if we take a line down there, and then we put another line on there, we've got 1, 2, 3, 4 parts, and we call those the quadrants, okay? So this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. So this is the graph of y equals sine x. The highest value in this graph is 1, the lowest value is minus 1. Now when we're talking about a function and the values of a function, everything which is above 0 is a positive value. So these are all your positive values in there here. The values of a function are the y values, or the up and down values. Everything below 0 are all the negative values. So that means that on the curve, these are the positive values in quadrants 1 and 2. If you go into quadrant 3 and 4, you're below the x-axis, so these are the negative values for that function. So the sine function is positive between 0 and this point, which is 180 degrees, and it's negative between 180 and 360 degrees. This point here, the highest point, corresponds to 90 degrees, and this guy here is at 270. So we're just going along 0, 90, 180, 270, 360. And we're just calling these 1, 2, 3, and 4 for these quadrants. But we can basically visualize that in a different way using this thing called the CAST diagram. So let me show you how that works. One of the things that students always wonder about this is why bother? Isn't this sufficient? Well, it kind of is. I mean, if you're very familiar with this graph, then you can use this to gain all the same information you could from the CAST diagram. As you move further into trigonometry, you'll find the CAST diagram is a quicker method of getting information that you would get off the graph. For some people prefer to stick with this. There's times when you've kind of got to use the CAST diagram, or it's very difficult to avoid it. But theoretically, you could sort of use either. But this is a great quick method, as you'll see in a moment. So the way that we do this, we label these as a quadrant. So this is quadrant 1, 2, 3, and 4. So we go counterclockwise. So this is 0 to 90 degrees, because that's quadrant 1, 0 to 90. This is 90 to 180 for quadrant 2. And then we go round to 270, and then back for the full cycle, back to 360, so back to 0. Okay, so it's just a different way of visualizing the four quadrants. Let me just move that 4 up a little. Okay, so 1, 2, 3, and 4. But what does that actually tell us? Well, we know that the sine function is positive in 1 and 2. So the way that we do this is we label on CAST, C-A-S-T, and where we write the letter, so remember this just means sine, tan, cos, and all. Where we write the letter, it means that that function is positive in that quadrant, and the all means all three functions are positive in the first quadrant. So that means that sine is positive here in the all quadrant and here, but it's negative here and here because this is tan and cos. Okay, confusing? Yeah, it's confusing at first. It's a little weird at first. So if you took a value for sine, like say 120 degrees, and if you wanted to know if that value, if you put that in the calculator, so if you wanted to do the sine, let me put it over here, if you wanted to do the sine of 120 degrees, and let's say you're doing a question where you don't necessarily need to know the value, you just want to know is it positive or is it negative? Well, from the graph, you would say, right, 120 is here, so this is 90, 100, 110, 120. If I go up till I meet the graph, it's way up here, And if I go over to the y-axis, that's definitely positive. That's in the positive part. So that's how I would get that information. But I had to draw the graph and kind of get the sketch reasonably accurate. But from there, that's telling me that this is positive. If I do the same thing on the sine diagram, I just say, right, on the cast diagram for sine, then I just say, right, 120 is in quadrant 2, so between 90 and 180, so I'd be in here. Well, sine is positive there, so I can see that it's positive. I didn't need to draw anything. And when you come to draw the cast diagram after a bit of experience, you won't be as detailed as I was there. You'll probably just go like this, C-A-S-T, and you say, okay, I'm looking for one in quadrant 2, that's there, between 90 and 180, so it's positive, and that's how you'll do it. Quickly, basically, rather than drawing the graph. So that's how it works. It's just transferring all the ideas from here, all the information from here, over to the diagram for the cast method. Let's take a look at the cosine function. It works for the tan function as well, but we're only going to go as far as the cosine function, just because the tan function's got a more complicated graph. It's a little trickier to deal with. So cosine function is just the sine function moved over a little. So it just basically comes out like this. It's just starting from here instead of starting from here. It's got a lot of the same features. So maximum value of 1, minimum value of -1. So that's at 1 there. This is at -1. Split in the quadrants. This is quadrant 1 here. Let me do it in the same colors actually. Oh no, I've changed the color of graph, so let me change it to red. So 1 there, 2 there, 3 there, and 4 there. So we just divide this middle bit into sort of 2 quadrants. So the key points for this one is 90 degrees corresponds to that point. The middle point is at 180 degrees. This point is at 270, and then the end point is at 360. So just those 90-degree divisions, the same as we had here, and the 90-degree divisions that we've also got on the cast diagram. So let's say that we were interested in some cosine values, like the cosine of 30 degrees. Well, 30 degrees according to the actual diagram of the cosine graph, 30 degrees is around there. So if we mark that on, 30 degrees, if we go up till we hit the graph and then over, we're going to land somewhere there. So that's definitely a positive value, so that tells me it's positive. Does the cast diagram say the same thing? So 30 degrees is in the first quadrant, so we would be here, so we put a little check there, and we say, well, okay, so remember that was 0 to 90, so that's why I've put the check there. That's got the A in it. A means all 3 functions are positive there, so that means that cosine is positive there, so that validates what we get. We should get the same information from here as we do from here. Let's look at another one. Let's have a go at, I'll stick with the red pen. So let's have a go at the cosine of 190 degrees. So 190, let's start with the cast diagram this time. 190, remember this is 180 here. So 190 would be somewhere down here. So between 180 and 270. So we would be checking in that third quadrant. So quadrant 3, the tan quadrant. In the tan quadrant, cosine is negative. So we expect it to be a negative value. If we look at it on the graph, well, 190 is about here. If we go down till we hit the graph, that's corresponding to a value very close to -1, which is definitely negative. So that validates that that should be a negative. So the cast diagram is just a very quick, efficient method of kind of redrawing this information in a quick, easy format without actually having to draw out the graphs. In the ideal world, you'll understand and be able to use the cast diagram and the graphs, because trigonometry spends quite a lot of time looking at the graphs of these functions, so it is important. When you come to things like trigonometric exact values, trigonometric equations in particular, you'll use these a lot, and you'll find that it's a quicker method often than drawing out the graphs. But in the ideal world, you should be comfortable with both. We never looked at the tan function, but the process for working with a tan function would just be the same. The cast diagram just tells you where tan is positive and where it's negative. So for the tan function, it's positive here and here, negative here and here. So that's basically how the cast diagram or the cast method works. Tricky at first, a lot of students have difficulty with this, and partly maybe because they're not quite comfortable yet with the graphs. Usually we do the graphs and then move to the cast diagram fairly quickly, sometimes at the same time. Quite a lot to get your head around, So be patient with this one. Don't expect to just look at it and think, yeah, that's easy, because it's not easy. It takes time and a little bit of persistence. So just go through that slowly, make sure that everything I've said there makes sense. And when it does, you'll be able to start answering questions using the graphs and using the cast diagram.